Hi, thank you for joining. I'm Chao from Dev Center 1, and I will be talking about upgrading the networking stack of Line iOS. First, some background. From last year's Dev Day session, there's a session called Linked, Line Improvement for Next 10 Years, and it covers upgrading the networking protocol of Line from the perspective of a server developer. And today's session is mainly from the point of view of an iOS client developer, and it is mainly about refactoring in a large project. And due to time constraint, certain networking technologies, such as the push optimization mentioned from last year's session, will not be covered. So I will start with the reason for upgrading, how we're doing it, and end with some lessons we learned from the process. Looking at our existing networking stack, we are using a SPDY library to implement the SPDY protocol. And as we all know, SPDY is already deprecated and absorbed into the HTTP2 standard. And we also have some customized business logic on top of the SPDY protocol, which makes it harder to upgrade the networking protocol alone. And also, our existing networking stack is a codebase mixing Objective-C and C. We're basically using CF network to create TCP connections by ourselves. And it is already widely adopted in our project. And our goal is to upgrade to standard HTTP2 and of course HTTP3 in the future. And we want to have a pure Swift codebase because the whole Line project is migrating to Swift. The most important is we want a smooth transition. We don't want our features to be affected. So from now on, I will name the SPDY networking as legacy networking. So currently the features are calling the legacy networking's interface directly. What we did first is we created an abstraction layer written in Swift, and we have the features called the abstraction layer instead. And behind the abstraction layer, we still call the legacy networking, so everything is still the same functionally. And what the abstraction layer does is basically it collects all the information needed for making a request. There's also a plugging mechanism. And what it does is we will call all the registered plugins for a request before we're going to send it from the abstraction layer to the networking layer, and after we have just received a response from the networking layer. And what we can do with it is, for example, we can implement a plugin that can turn on or off the network activity indicator. Or we can implement a plugin to log the request and the response. We can even do something more complex, such as modifying the headers of a request before sending it. And after receiving the response, we check for a special header and do something special. So you get the idea. The plugin mechanism allows us to pack the business logic in a modularized way, because each business logic can be implemented in a single plugin. Also, the business logic is separated from the actual networking implementation, which allows us to upgrade the networking implementation in the future easier. So we gradually migrated all features from calling the legacy networking directly to calling the abstraction layer instead. We migrated over 500 calls, networking calls, divided into more than 70 tasks. And we can do this progressively and concurrently. And we have enough time to make sure our features are not affected during the migration. So now we have the structure ready, and we can start implementing the HTTP2 behind the abstraction layer. So we wrote something like a switcher that can switch between networking implementations. Some facts about our HTTP2 implementation is we first tried some simple wrapper over URL session, but then found some problems with it. So now we're trying Swift Neo HTTP2. When we have our HTTP2 networking ready, we would like to switch to it behind the abstraction layer. But since it is not battle tested, issues are expected to happen. So we have a server-controlled flag in the switcher, which allows us to switch the networking on the fly. So whenever an issue is identified, we can switch back to legacy networking immediately and switch HTTP2 back on again after we have fixed the issue. And we plan to do this switching back and forth in 3 phases. We first do it for development environment, then for QA environment. Then when we think we're ready, we will progressively roll it out for real environment. And finally, some lessons we learned from the process. When you have some legacy code you want to get rid of and you feel it is a little hard to do so, consider using an abstraction layer to isolate your legacy code. And then you can write your new code side by side with your legacy code. And you have the ability to switch back to your legacy code anytime until your new implementation are robust enough. And also, having a clear separation of different abstraction levels helps. In our case, having a separation between the abstraction layer and the actual networking implementation makes it easier for us to upgrade the networking implementation alone in the future. And here are some references if you're interested in learning more about abstraction layers and Swift Neo. Thank you.